When we discussed proportions, we talked about how two ratios that were equal were called a proportion. We then found out how to solve for a missing term in a proportion. Now let's apply that to similar figures. Our goal is to find missing lengths in similar figures, but first we need to know what similar figures are. Well, they have the same shape, but not necessarily the same size. You can use proportions to find a missing sign length, and this is the symbol for similar to. We'll look at two triangles. In similar figures, the measures of the corresponding angles are equal, and the corresponding sides are in proportion. So let's take a look at that. If I wanted to talk about corresponding sides, AB corresponds to FG. Let's take a look at another one. Let's look at AC. AC corresponds to FH. And then we'll look at BC. BC corresponds to GH. So we're looking at corresponding sides. They're in the same relative position, and we're going to find out that they are in proportion. Let's now talk about the angles. We're going to look at angles, and we're going to stop and say that angle A is equal to angle F. Angle B is equal to angle G. And angle C has the same measure as angle H. So we're going to be talking about, once again, this relative position of things as corresponding sides and angles. The word congruent means the same measure, and this is the symbol for that. So now let's talk about filling this in. I already showed you by highlighting it on the figure, but let's talk about that again. If we take a look again, angle A, we said, corresponds to angle F. Angle B will correspond to angle G. And then we have angle C, let's go back up, will correspond with angle H. In the last lesson, we also learned that proportion states that the ratios are equal. So now if I go back and look at how I colored in that figure, we can see that each of these corresponding sides is in a ratio, and the ratios form a proportion. In the figures in each pair, they are similar. Now you're being told that they are similar. You don't have to test it out. Identify the corresponding angles and sides. So again, we could say that angle A corresponds to and is congruent to angle E. We could say that angle B is congruent to angle F. Keep going. Angle C is in the same corresponding spot as angle G, so they are also equal or congruent. And angle D is congruent to angle H. So right away we spent a moment there just looking at those corresponding angles. Now let's talk about the corresponding sides. The corresponding sides, well, AB corresponds with EF. So these two are corresponding. Let's take a look at BC. BC and FG are corresponding. Let's go on to CD. CD corresponds to GH. And lastly, we have HE. I'm sorry, we have, I guess we have HE here corresponds to DA. Try to keep it in the same order, okay? We can do the same with these two triangles. We can notice that MN corresponds to PQ, so MN and PQ, I'm sorry, MN and SQ. We can see that QR goes with NO. And that leaves us with, let's see, what didn't I do? SR. And that will go with MO. And we could do the same with the angles as well. So just talking about same relative position, they correspond. So let's find the missing length of a side. We're going to set up that proportion, and we need to find the measure of DE. We do not know what this is right here. So I'm going to put that X there, but technically they're using DE. I would replace it with a variable. So write the proportion. BC, so this side here is in the same corresponding side space as this one here. So BC is to EF as AB. All right, let's change that color so we can see that. AB is to DE. So I put it here as the book did with a DE, but I would put a variable there. So again, we can now look at this, and like I said, I would put 16, which is the measure of BC, is to 13 as, we're going to put the measure of 10, which is AB. I'm just going to put an X there. It's easier to solve. So now let's do the cross products. 16x is equal to 12 times 10. Go ahead and multiply. And lastly, divide. And that missing measure is 7 5/10. So now we can go back and fill in x is equal to 7 5/10. Helps us to find the missing measures. The figures in this pair are similar. Find the missing length. Again, set up that proportion. This side here is in the same corresponding spot as this side, so they're in a ratio, they're comparison. So I've got 9 is to x as 11 is to 14. Again, cross multiply and solve. Go ahead and finish that one up. Now, one last thing, a scale drawing is simply a drawing that is similar to the actual object or place. You have things like floor plans and blueprints and maps and models. You know, I have a toy model of a race car or a boat or a plane. They're all examples of scale drawings or scale models. In a scale drawing, the ratio of any length on the drawing is to the actual length is always the same. And the ratio is called the scale of the drawing. So imagine that we're looking at a map, and on this map it tells you that for every inch it's equal to an actual 110 miles. So if the distance between two cities is 3 2/10 inches on the map, what is the actual distance? So we would go and set up that proportion again. 1 inch is to 110, so this is now inches to miles, and we have to be careful with this because we want to go inches to miles once again. So I know the 3 2/10. What I don't know is the miles. So all I need to do is cross multiply to solve. Once again, find your answer. We'll do a little bit more practice of this for our assignment today, and if you have questions, bring them to the next class.